Hey guys! In this video, we're going to find out what is causing the switch to brick. We have two Nintendo Switch with firmware 5.1.0, a Polder Pro, and a bunch of third-party ducts. Here's a special thanks to George Calvo, one of our backers. He got this Polder Pro a couple of months ago, and his Switch was unable to charge after being connected to the Polder with an official AC adapter after roughly 30 minutes. The company posted an announcement to warn their backers not to charge the Polder Pro when it was connected to the Switch. But it was too late. Some first wave backers already had their Switch bricked by the Polder Pro. It took us about 3 weeks to receive this Polder, which is why we're behind schedule with this video. Here are some of the protective circuit boards which will be used as firewalls to protect the Switch. So if the dock is bad, it will fry the circuit board first, and the LED light in the circuit board will tell us if the board is damaged or not. We will use an oscilloscope during this test since we are more focused on the power. It will show us how much voltage and amperage the dock delivers to the Switch. First of all, let's think about what is causing the Switch to brick. The general consensus thus far states that the bricking is actually caused by the damage of the M92 T36 chip. The fried chip is a result of overvoltage or overcurrent, which are caused by PD protocol errors. Since PD protocol is quite difficult to understand, it would be impossible to explain how it works in just one video. However, the curve of voltage and current are easy to understand, and is also the direct cause of bricking. So we will focus on voltage and current in this video. Let's test the Polder Pro first. When you connect the Switch to the Polder Pro, the Polder will charge your Switch just like a power bank, but sometimes the Switch will charge the Polder. It seems that the Polder's work logic is very confusing. We simulated George's scenario when his Switch was bricked. We connected the Switch with the Polder and plugged in the Nintendo Switch AC adapter. The oscilloscope showed an abnormal voltage. The Polder sent the 15-volt power output directly to the Switch, and the Switch repeatedly rejected the power. As we discovered this strange behavior, we immediately disconnected them, but we found it was too late. Our Switch had already been damaged. Now only one side of the USB-C port worked. This is because Polder's 15 volts are received at the same time that the Switch outputs 5 volts to the Polder, and these 15 volts are not through any of the configuration channels or PD protocols. In fact, there is no PD protocol at all. It's completely wrong. According to the PD protocol regulation, it must have a 5-volt application before upgrading to 15 volts. Our protective circuit board didn't work, which means that its output voltage does not exceed 20-volt VBus. However, after a short time, the power management component in the Switch was cooked by the frequent impact of 15 volts. Please note that the Polder Pro that we tested is from the first production batch. Let's move on to other third-party docks. This hub is a very common design that you can easily buy on Amazon and eBay. The brands are all laser etched and they may be made by one manufacturer. We found that when it was connected to the Switch, there was a small glitch. The configuration channel was lost, and then the Switch was quickly reconnected. 15 volts was delivered directly to the Switch immediately. Again, if it was PD protocol compliant, it should deliver 15 volts before upgrading to 15 volts. During the test, it did not brick our Switch, but it has a potential risk of bricking the Switch. We also tested the Nyko dock and we discovered a quirk in the PD protocol in the dock. When we plug in a third-party AC adapter with multiple outputs, it defaults to the second level output. For example, your AC adapter has 5 volts 3 amps, 9 volts 3 amps, 12 volts 3 amps, 15 volts 3 amps, and 20 volts 2.25 amps. The Nyko dock will only choose 9 volts 3 amps, which is the second output tier to deliver to the Switch, ignoring the request for 15 volts from the Switch. Thus, the Nyko dock protocol is problematic. It will only deliver the second output to the Switch instead of choosing the correct output that the Switch requires. And the Nyko dock does not work with some of the third-party AC adapters, even those adapters which have 15 volts output. It can be presumed that the Nyko PD protocol is not designed based on the standard PD protocol. In our experience, this is a PD protocol error, but it does not cause the Switch to brick. We didn't find the real cause of the bricking issue, and our Switch survived during this test. We will continue our testing and inform you guys as soon as we find the problem. Now let's take a look at the performance of the official Nintendo dock. After the switch was connected with the dock, we can see that the dock delivers 5 volts, CC connects and then upgrades to 15 volts. There is a 15 volt 0.5 amp action, which can be seen as a request for TV mode. Once the HDMI is connected, the system will switch to TV mode if the 15 volts and 0.5 amps are met. After that, the voltage and current are very stable. Next is the Jumpgate. After connecting our dock to the switch, the Jumpgate delivered 5 volts to the switch, CC connected and then upgraded to 15 volts. Thereafter, the voltage and current were as stable as the official Nintendo dock. As you can see, the Jumpgate has a very solid performance. Our PD protocols have been optimized to be compatible with the Nintendo Switch. In short, the Jumpgate is just a bridge between the Switch and the AC adapter. It listens to the Switch and completely obeys the order from the system. Now it's time to draw a conclusion. What is the real issue of the Switch being bricked? A USB A to C cable that does not have a 56 ohm resistor. Some USB A to C cables use the wrong resistors. Some don't even have one. This can cause the Switch to misjudge whether the power adapters or USB ports support the 5 volt 3 amp standard, forcibly sucking 3 amps of current, resulting in damage to the power adapter and switch due to overcurrent. A PD protocol that is not standards compliant. We found some docks or hubs have PD protocols in the microcontroller unit, rather than a professionally designed PD chip. MCUs are not as stable as PD chips, so it makes sense that those manufacturers who put PD protocols in their MCU lack experience and don't have professional suppliers making good PD chips, or professional PD engineers optimizing their own PD protocols to be compatible with the PD protocols in the Switch. The PD protocols that are not standards compliant will lead to unpredictable consequences or even possibly cause your Switch to brick. This is our first test on the bricking issue. We would like to continue our testing and we will definitely make more videos about this issue. Please share your thoughts with us by leaving your comments down below. Thanks for watching.